making changes to these guys more than just the MUT table changes that we've done so far in order to enable advanced logging. Hi, this is Recompile, and in this video we're going to go over how to interpret an EvoScan data log and how to relate that to EcuFlash and how to actually begin tuning your Evo. So this is geared towards newcomers. If you're already familiar with how to interpret an EvoScan log and how to make basic edits to EcuFlash, you may want to skip this video, but it's also a good beginner to intermediate level if you just want to get familiar with the basics of interpreting a data log and how to correlate that into changes that should be made in your tune in EcuFlash. So EvoScan creates comma-separated data log files, and it stores them in the EvoScan Save Data Logs folder under Program Files, EvoScan, your version number, and Save Data Logs. I've created a subfolder just for my particular logs because I've got logs from other people also on this laptop. So as you can see, I've got a whole heck of a lot of data logs here that I've done to my car over the months. I just picked any random one at any time. This is one from last year. So ideally, you'd look at something like this, a comma-separated value file in a spreadsheet program like Excel. Gives you a nice breakdown of all the values that you've logged. So at the first row, we've got the header entry to tell you what's in this column. One of the nice features of Excel is being able to filter specific values, and particularly what I was tuning on this particular poll, it looks like, this particular data log, is a wide open throttle pull where throttle position is 100%. So if that's all we care about for this log, I'll just go in here and set a filter for throttle position equal to 100%. So all that does is hide any type of non-full throttle data that might be in this log. You can use that for various different tuning needs. If you need to look at specifically maybe where your wideband went extremely rich or extremely lean, or maybe you're looking at a certain RPM range, you can set limits with the filter option in Excel. So with that filter, we know we're looking at the data that we really care about, and we can now begin to understand exactly what happened to the car as we went through this full throttle pull. So it looks like we started at about 3160 RPM, and at that time, logging our 2-byte load, as we described how to set that up in the previous video, at this time was 280 load, airflow of about just over 1000 Hertz, with 4 degrees of ignition timing. We don't happen to have a wideband item from this particular moment in time, but that's not uncommon when logging an external wideband. Sometimes they just don't match up to exactly the same logging rate as EvoScan can with the MUT protocol. So there may be some gaps depending on what can log faster. We happen to have 0 knock at this moment in time. That's great. Now you'll notice that boost or JDM map, as it's sometimes referred to, is available on my log, but this isn't available to you from the factory with a typical Evo 8 or 9. And the reason is because the stock Evo map sensor is not a 3-bar map sensor. It doesn't allow you to log any significant accurate levels of boost experienced in the intake manifold. But luckily you can get one from Japan, or you can get one from, I believe the US dealerships now sell them as Evo 10 map sensors, and these will actually allow you to log with EvoScan what the manifold pressure is in the intake manifold. So now you don't have to visually look at a boost gauge to log boost or to tune boost. You can log that along with everything else side by side and really make use of EvoScan and EcuFlash. So that's an intermediate level use of EcuFlash and EvoScan to your advantage, being able to log boost. It's really helpful. You can actually use it as well to control boost, to basically convert the stock ECU into a full PSI programmable electronic boost controller. So you can save yourself a few $100 and just get a JDM map sensor, put it in, make the changes in EcuFlash, make the changes in EvoScan, and you can log and control boost directly. So these are the kind of really great things that some of the disassemblers and developers have determined over the years of how to fully utilize the capabilities of the stock ECU. It's one of the real reasons that make it one of the best ECUs that I've seen from the factory. So I'm logging boost at this point in time is 24.7 pounds, and I'm also in this instance logging wastegate duty cycle and other things, injector duty cycle, and so on. So what we really need to worry about, probably first and foremost, the most obvious way to understand how your tune is operating, and the most glaring of things that you can log that would identify possible problems in your tune, would be knock or knock sum. In this case, looks like through most of this wide open throttle pull, we're not experiencing any knock, which is great. As we scroll down, getting through the RPM band here, 6,000, 65. Okay, so we started to experience knock at 6,636 RPM. We experienced 3 counts of knock. Now, knock